Let's dive right into this explainer. Today, we're looking way beyond the surface of body art to explore the unseen, highly active biological journey of tattoo ink. I mean, we see tattoos literally every single day, right? From tiny, minimalist designs to massive, incredibly vibrant full sleeves. But while the cultural meaning is right there on the surface for everyone to see, the biological consequences going on underneath, those are practically invisible. And honestly, they're absolutely fascinating. So, you might be wondering, once the needle actually stops buzzing, where does all that ink actually go? It's a great question, because a tattoo might look like just a permanent piece of surface art, but beneath the skin, it's triggering a lifelong biological and chemical interaction. Scientists are honestly just beginning to understand this. Growing evidence shows that tattoo inks are not biologically inert. They don't just sit there doing nothing. So the real question isn't whether tattoos introduce foreign substances into us, but how those substances behave inside our bodies over a lifetime.
Which brings us to Section 1, the chemical cocktail.
To understand the biological side of things, we really need to look at what's actually inside the needle. Let's deconstruct the ink itself to see exactly what's being injected into the dermis. Tattoo inks are incredibly complex chemical mixtures. They've got pigments for that vibrant color, liquid carriers to actually get the ink into your skin, and preservatives to fight off microbes. But here's the truly shocking part. Many of the pigments used today, they were originally developed for industrial applications. Yeah, we're talking about chemicals formulated for car paint, plastics, and printer toner. Not exactly stuff designed to be injected into human tissue.
And that brilliantly illustrates the harsh reality of these chemicals, especially when we break it down by ink type. Black inks, which are usually made from carbon black, often contain polycyclic aromatic hydrocarbons, or PAHs. These are the exact same compounds produced when you burn organic matter, stuff you'd find in soot or vehicle exhaust, and some of them are known carcinogens. Then you have colored inks, especially the reds, yellows, and oranges. These frequently harbor heavy metals, like nickel, chromium, and cobalt, along with synthetic azo dyes. It's no wonder these colored inks are way more frequently linked to allergic reactions and chronic inflammation.
Now, what's really wild is how these chemicals can react to their environment over time. Take azotio dyes, for instance. They are synthetic colorants used a lot in textiles, but under certain conditions, like prolonged exposure to UV sunlight or even during laser tattoo removal, these dyes can literally break down into toxic compounds called aromatic amines. In lab studies, these degraded chemicals have been linked to genetic damage. It just proves that a tattoo isn't a static image, it's a dynamic, chemical presence in your body.
All right, moving on to Section 2, the battle in the dermis. Let's look at the next stage of our journey and see how this creates a literal cellular battlefield right beneath your skin. This process is absolutely mind-blowing. The beautiful permanence of a tattoo is actually the result of a microscopic failure. Here's what happens. The needle injects the ink deep into the dermis layer. Immediately, your body spots these pigment particles and flags them as foreign invaders. So your immune cells, specifically macrophages, rush in to devour and clear them out. But the industrial particles are just way too big to be destroyed. The immune cells eat them, but then they die, permanently trapping the ink right there in the skin tissue. That microscopic stalemate is exactly what makes your tattoo permanent.
But, the immune system doesn't always just throw in the towel. For some people, this ongoing struggle causes persistent itching, swelling, and what are known as granulomas. Basically, a granuloma is a small inflammatory nodule that forms when your immune system keeps trying to isolate foreign material that it just can't get rid of. This happens a lot with red ink, and these intense inflammatory reactions can pop up out of nowhere, sometimes months or literally years after you got the tattoo.
Next up, Section 3, migration to lymph nodes.
So, the story totally doesn't end in the skin. The crucial point here is that not all of the ink stays trapped on that dermal battlefield. Some of those industrial invaders actually manage to escape. To see where they go, we have to look at your lymph nodes. These are those small, vital structures that filter immune cells and coordinate your body's immune defense network. Studies actually show that escaped pigment particles physically migrate through the lymphatic system and pile up right inside these nodes. So the very structures meant to protect you end up acting as storage for heavy metals and organic toxins.
And as you'd guess, it causes a reaction. When those ink-engorged immune cells die in the skin, they release distress signals. These signals travel straight to the lymph nodes and keep the immune system constantly activated. Recent research shows this can drive inflammation in these vital coordination centers for up to 2 whole months after getting inked. Your body is basically just stuck on high alert.
Let's get into Section 4, altering the immune system. Which brings us to a really massive revelation. Let's zoom out from the cellular level and see what this means for your body's overall systemic defenses. We're now learning that tattoos might do a lot more than just cause local inflammation. See, in a normal immune system, your body uses incredibly precise chemical signaling to coordinate responses to things like infections or vaccines. But in a tattoo-altered system, recent research suggests these trapped pigments can actively jam that immune signaling. The vital chemical communication system your body relies on gets disrupted just by the presence of these industrial inks.
To see this in action, researchers actually looked at vaccines. They found that having tattoo ink at a vaccine injection site was associated with a reduced immune response, specifically to the COVID-19 vaccine. Now, let me be absolutely clear here. This doesn't mean vaccines are suddenly unsafe or that you shouldn't get them. Not at all. But it perfectly demonstrates how ink can locally alter a vaccine-specific immune response by messing with that critical chemical communication. Finally, Section 5. Long-term health unknowns.
So what does this all mean for us down the line? Well, because widespread heavy tattooing is a relatively recent cultural trend, we are essentially flying blind when it comes to decades-long systemic exposure. When you start adding up the variables, the unknowns really pile up. For starters, global chemical regulation is severely lacking. Plus, you have to factor in a lifetime of sun exposure, the natural aging process, and shifting immune functions. It's like a giant puzzle. And for people with autoimmune conditions, these risks are definitely heightened. We also can't forget the immediate infection risks from the needle itself, like staph or hepatitis B and C.
Ultimately, it comes down to what this quote hits on perfectly: cumulative exposure. For most people, a tattoo won't cause immediate, serious health problems, but they aren't totally risk-free. As our cultural canvas grows bigger, with people getting full sleeves, massive back pieces, and incredibly colorful designs, we are exponentially increasing our lifelong chemical burden. We are quite literally filling our bodies with substances that were never designed for long-term residence in human tissue.
Tattoos are an incredibly powerful, beautiful form of self-expression, no doubt about it. But as this explainer shows, they are also a lifelong biological commitment. The ink doesn't just sit there on your skin. It interacts with your immune system, travels to your lymph nodes, and could potentially alter your body's internal signaling forever. Which leaves us with a pretty massive question. As permanent body art continues to explode in popularity worldwide, what toll does this actually take on our bodies over a lifetime? And are we really prepared for that level of chemical exposure? It's definitely something to chew on before booking your next session in the chair.